a slightly different lesson here because in this particular lesson, I'm just going to walk through some solutions. I'm actually going to bring up the scoring guide, the exam preparation of these questions, of this particular question here. Example 1. Example 2 will be a separate video where I'll actually walk through the solutions. But in this one, because it's such a calculator-oriented lesson, I want to show a lot on the screen with the calculator. So the solutions, I just want to match them up with what you see on the screen. So here's the problem. A particle moves along a straight line for 0 less than or equal to t, less than or equal to 5. The velocity is given by, and there's a nice velocity function there. And the position of the particle is given by s at t, but they don't give me s at t. They just say that's the equation we're going to use, or sorry, the symbol we're going to use. And it is known that s at 0 equals 10. So I have a velocity function for the particle, but I also have its initial position, s at 0 equals 10. And it says find all the values of t in the interval from 2 to 4 for which the speed of the particle is 2. Now notice it said speed there. And so there's different ways to handle the speed situation because they want to know not just when the velocity of the particle is 2, but also when the velocity of the particle is negative 2. And that's one way you could handle it. You could graph this function v at t and then just find out when it's 2 or negative 2. I'm going to add a little bit to it so you can see a little bit more of the functions of the calculator, but feel free to do it any way that you can get there. So I'm going to go into my calculator here and graph. I want to note that this particular ROM that I'm using for this calculator might be slightly different version than what your calculator has. So if I press a button, it might not be the exact same button that you press on yours. You might have to just look on your calculator and see where a certain function is that you're looking for. Okay, so I'm going to try and graph the speed function, not the velocity function here. And to graph the speed function, I'm going to have to do absolute value. And no easy way to get absolute value because the absolute value doesn't really appear as one of the functions on the page here. So what I'm going to go into is the catalog. And if you haven't seen that before, the catalog is a nice list in these calculators of all the functions the calculator will do. And one of the functions down, if I just scroll down, is absolute value. It doesn't show the absolute value bars. It just says ABS for absolute value. So I'm going to do the absolute value of this velocity function. Again, if that's confusing at all, just graph the whole function as is. Don't you do the absolute value. But because it's asking for speed, look for when the speed is 2 and also when it's negative 2. And then you get the same answers as me. Absolute value. Okay, so here comes the function negative 2 plus x squared plus 3x. Close that brackets, then do an exponent. And I always put a bracket around the exponent because some calculators deal with the exponent differently. So I'm doing exponent 6 over 5 and then close the bracket for the exponent. Then I know that's done. And then I know the calculator's right with me as far as that's concerned. Then close the bracket for the whole thing. Press enter and then draw that thing. And I get this crazy picture here. And I want to know when is that function equal to 2. And you could use trace in here, and you could just follow along the graph and find out when it has certain values. And there's other functions in the calculator that let you find when that function is equal to 2. I find the easiest way for me is I just go back into the graphs here and I say, okay, make y equal 2. A second graph I'm going to put on there. When I draw it there, then I get a line at y equals 2. And what I really want is to know when do these graphs intersect. That is, when is my speed graph come out to the same value as this y equals 2. So that's exactly finding when is this function equal to 2. So then I can use GSolve, one of the most powerful buttons on this calculator, because it gives me all these options here. I can find the roots, the maximum, the y-intercept, the intersection, and on the other menu, a certain y value or x value. So I could actually use that right there to find y value too if I wanted as well. So that's a good function there. I'm going to use intersection, and it immediately grabs an intersection point at negative 1.15. That's not what I want because it asked me for values between 2 and 4. So I just right arrow over and it says, oh, it's that value at 0, but I don't want that one either. I want the ones between 2 and 4. There's 0.94. Maybe it looks like it might be close, but it's not between 2 and 4. I just keep right arrowing over, and then I get the 3.127 value that you see in the solution over there, and I right arrow over, and I get this 3.47 value. Okay. Next question is write an expression involving an integral that gives the position of s at t. Use this expression to find the position of the particle at time t equals 5. So find s at t at a certain value, I want to know where does it start. So there, that's why they have the 10 there, is the s at t will be 10 plus whatever additions you have to, or subtractions you have to make from the velocity. So the net change in position is given by the integral of velocity. And so the integral of velocity is given there. You take from, you start at 10, and then you add on the additions or subtractions from the velocity. So you go from 0 to t of v at x dx. And then I, in the function there, the control v at x there, I didn't write the whole function in there. If I used x here, again, t would have worked fine. So to find the value at s at 5, you see, now we do have a limit of summation. Instead of from 0 to t, we know we're going from 0 to 5. We want to add on velocity pieces from 0 to 5. And then they just wrote the answer there. But to type it in my calculator, I got to go back to the regular menu here. And I notice I don't have math down here. And when I don't have math down there, I must be in the wrong mode. So I go into setup and switch over to math mode. And when I come back out, then I'll have my math button. And so I hit the math button, and what I want is an integral. So I'm going 10 plus, just arrow over here, and here's the integral button. Such a powerful button. And so I need the whole function again, so I got to type the whole thing in again. Negative 2 plus, open bracket, x squared plus 3x, close that bracket, exponent, and well, this one gave me exponent. When I'm in this mode, it gave me an exponent there. So I'm not quite so worried about that exponent. It wouldn't let me use the fraction button up there, so I went 6 divided by 5. But I'm not so worried about having a bracket in that exponent because it's showing me where the bracket is. And then minus x cubed. Oops, I didn't get that exponent in there just right, so x cubed. And then right arrow over from there. Lower limit of summation, I already forget what I'm at here. Oh, I'm going from 0 to 5. So 0 up to 5. And then when I press equals, I get negative 9.207 that thereafter. Okay. C, find all the times when the particle changes direction. Justify your answer. Well, to see when it changes direction, I want to know when the velocity goes from positive to negative. And so when I go back to my graph here, I'm going to get rid of that absolute value. Well, first of all, I'm going to get rid of that y equals 2. I don't need that anymore. And I don't know what it's going to do when I delete this. Right there and go delete. Is it just going to let me do that? Yeah, okay, good. Enter and then draw. And then I get the whole velocity function here. And what I'm going to do is zoom out. I want to show that function too. Zoom out and zoom in, zoom out on this calculator. Sometimes works really good, and sometimes it doesn't work very good. And so you just have to play with that. Sometimes you have to go right to the V window. But the zoom out works pretty well. Now, what I want to know is when the velocity. So this is the graph of velocity now. And over here in this section of the graph, the velocity is positive. I don't really care about that section. And then in this little section here, the velocity is negative, and then it goes to positive velocity and then to negative velocity. I'm going to change direction. I need the velocity to go from negative to positive, which is right there on the screen there. My arrow's pointing right at it. It's going from negative velocity down here to positive velocity over there. Negative values to positive values. What I want in my GSolve then, this time, is the roots. And it found this root at negative 0.66, which I don't care about because I only want ones that are positive. So I'm just going to arrow over to the next root. And the next root is this 0.536033. And that's when it changes from negative velocity to positive velocity. That would be changing direction. And then there's one more over at 3.317. That's when it goes from positive velocity to negative velocity. Very nice. You get those answers very, very quickly on there. And if you didn't do absolute value, then you could have done it even faster because you would have had the regular velocity graph all ready to rock and roll. Last question. Is the speed of the particle increasing or decreasing at time t equals 4? This is a very difficult question because to talk about when the speed of something is increasing, what has to happen is your acceleration has to be in the same direction as your velocity. That is, if you have positive velocity, you also have to have positive acceleration. And if you have negative velocity, you must also have negative acceleration. Just because you know the acceleration is positive or negative, you also need to know the sign of the velocity. Because to be speeding up, and getting more speed, you can't have the acceleration acting against the velocity. Okay, so sort of a physicsy type thing there. So v at 4 equals negative 11.47 is what they've got there. They found the velocity. So they just asked at a specific time here, at time equals 4, what's happening there. So first thing, let's find out what the velocity is at t equals 4 using the calculator. And that's a fairly simple procedure. I'm going to go back to this, and I'm just going to type in the v at t function, but I'm going to, whenever I see t, I'm just going to put in 4. Okay, so negative 2 plus, you'd think I'd have it memorized by now, I've typed it in so many times, but 4 squared plus 3 times 4, close that bracket, exponent. Oh, it gave me the exponent this time, so I'm a little less worried about the brackets. Still won't let me use the fraction button in the exponent, so I'll just go 6 divided by 5. Maybe your version of the calculator will. And then down here, minus 4 to the power of 3. And when I press equals, I get negative 11.47. And the fact that it's negative 11.47 is very interesting. But all I really care about is that it's negative. I got negative velocity. Okay, next I want to know the acceleration. Now I could go through, this isn't the worst derivative ever to find the acceleration. I could do that by hand. But if it's a calculator question, there is a slightly better way. Is I can go to the math menu, and this is really nice, d by dx. And when I hit that d by dx button, it gives me a function, but I can also sub in the x value, which is so nice. So I sub in that whole function again, d by dx. Negative 2 plus x squared plus 3x, and then exponent, oops, oh, it jumped right off of there. Well, the x value is 4. It's going to let me back in. No, it doesn't want to let me back in. Close that bracket. Oh, now I closed that inner bracket. Oh, see, I went outside that bracket. That's why. Okay. And then exponent, and then 6. Again, it doesn't want to let me do that, so I'm going to go 6 divided by 5 off of there, and then minus x cubed. I got distracted there, so let me just make sure I type that in right. Negative 2 plus x squared plus 3x to the 6/5 minus x cubed, and at value x equals 4. This is the derivative of velocity at x equals 4. So this is acceleration at x equals 4, and they get negative 22. That's what we see down there. And so here's the conclusion. If velocity is negative and the acceleration is negative, what that means is the acceleration is making the velocity more negative, and that's increasing the speed. So the speed is increasing at time t equals 4 because velocity and acceleration have the same sign. Okay, so there, a quick lesson on calculators, and see the second part of the video where I walk through this very difficult example, but I'll walk through it instead of using this scoring guide and the solutions. I'll actually go walk through the example step by step.